So thought I'd start off with this slide. When you work in mechanical harvesting, you get to be out in the orchard early, a lot of mornings. And this is one of the sunrises looking toward the Sierras at Rocky Hill Ranch down in Visalia, working.
Louise, we just need to turn on your
Oh, I thought it was on.
mic. It is on. Yeah.
It is on. Okay. Down in Visalia, California. Okay. And this is a representation of what we produce in California. It's the California black ripe table olive. The black ripe refers to what we do to it in processing. It is harvested physiologically immature. The olive is still a green color with slight purple shading, you'll see when we harvest it. And it being physiologically immature, the abscission zone is not formed. And each of these olives has a pull force of somewhere between 1 and 1.5 pounds when they're that stage. Oil olives are physiologically mature. They have a pull force of perhaps 1/10 that. Okay, so I'm going to start talking to you about traditional table olives in California. It is a legacy industry. The olives were brought to California by the mission friars from Mexico. They were originally introduced to Mexico by Spanish friars in this part of the world. At one point, some of the friars or fathers got into a fight. Some of them decamped to California, bringing olives and citrus with them. They established a series of missions, one day's walk apart up the coast of California. And the olives they carried with them got known as mission olives. Interestingly, that didn't carry over to the citrus. But what we have, olives are a legacy industry in California, and the climate is beautifully suited to it. Olives like a Mediterranean climate, a mild winter with rains, and a hot, dry summer with low humidity. The traditional olive industry, can everybody hear me well? Okay, thank you. The traditional olive industry, basically the trees were largely unpruned except for a little interior canopy pruning that would allow light into the canopy, though most of the fruit is borne on the outer 36 inches. But what I'd like to show you here is this is how the traditional olive industry has developed. That's an 18-foot ladder. That's a 20-foot or 20-pound picking bucket. It's a kick ladder. Sometimes it's just a leaning ladder with no legs. Sometimes it's a kick ladder. And the pickers wear knitted cotton gloves, and they strip down the chute into the bucket. Then they walk down that ladder and they dump it into a field bin usually. That's the traditional form and still the main form of olive harvesting in California. This harvesting currently now costs about 50 to 60% of the gross return on olives. The best price we get on olives is $1,200, $1,300, $1,400 a ton, shooting for 5 tons to the acre. The price has remained static for the past 20 years. Okay, so this is the reason that our olive industry has now declined. When I came to California in 1984, we had 38,000 acres, about 17 processors. We are now down to probably 13,000 acres and 2 major processors, one of whom has been purchased or is allied with a Spanish company and relies on imports. But this is the real reason that the California olive industry is declining. The pickers that I knew 30 years ago or 35 years ago that could pick a ton a day, they aren't available anymore, frankly. They aren't affordable, and they don't have the ability that they had. And I don't blame them. After they've established themselves, their children don't want to do this for a living. So this is the reason that the California olive industry is declining. If the trees are lucky, they get to go live in LA in somebody's landscaping. If they aren't lucky, this is what happens to them. I mean, this was 1% of California's acreage down in Terabella going out in one fell swoop. So the California industry, a legacy industry, is declining, and the reason is first, harvesting costs, and second, pruning costs. On the other hand, the California oil olive industry is booming. In the past decade, it's gone from about 4,000 to 40,000 acres, still increasing. And the reason is, first, they had cultivars that were bred to crop up quickly, stay small. Those trees are probably no more than, after pruning, 4 to 5 feet tall, and about a meter wide. That's about 3.5 feet. They are totally mechanically pruned, except for a few hand cuts to let in light, and they are mechanically harvested. And the mechanical harvesting costs about 15% of the gross return. The other thing is that most of the big oil operations are vertically integrated. They grow and they process and they market in-house. So staring us in the face is we have our solution. It's just getting there, okay? So there are distinct steps to developing mechanical harvesting. I'm going to try and use my cursor here now. So first, when you develop mechanical harvesting, you have to develop a removal method, something that gets your fruit off the tree. And it's the same. Then you have to prove this method produces a marketable product, whether it's fresh or processed, and you have to prove that it doesn't harm the tree. Those are your first steps. Then after that, you start developing prototype, excuse me. This is going, I went backwards. This is going forward, even though I'm pushing a different button over there. Okay. I'm a Mac person. These PCs scare me. Okay. Then you have to develop a prototype harvester. And then you start working simultaneously on the tree, the orchard, and the harvester to improve the efficiency to a point that you can start to equal or at least approach the net return of hand harvesting. Now, the major point here is simultaneously. And there's, in trying to do this, in addition to working with the harvester itself, building a prototype, testing it out in the field for efficiency of removal and for how long it takes for capacity, you start to work with the orchard. And you have 3 ways to work with the orchard. First, you can work with pruning. Pruning, specifically pruning the orchards that you have. That's a short-term solution, but it's one that you can start with. Then you start working with orchard design, meaning this is a midterm solution, maybe making the, when you plant a new orchard, making it more closely spaced, keeping the trees small from the beginning rather than having to do rejuvenation pruning. And then third, you can work with genetics, and I see I put short term there, and that's the wrong word. I meant to put long term. I'm sorry, thank you. Now I catch it as I'm watching. And this is what they did in the Spanish industry. They spent about 20 or 30 years developing smaller cultivars that crop up quickly and are suitable for mechanical harvesting at high density so they get early yields. Then down there in red is the big sticking point. Industries develop, or excuse me, universities develop technology and demonstrate how to use it, but we do not deliver turnkey. We do not fabricate machines. And the big sticking point in mechanical harvesting is once we've done all our work, taking it to the industry and saying, here are the blueprints, which is what we've done with olives, or here are the specs, fabricate a machine. And the first thing they'll say is, how many acres you got? And I'll say, well, 14,000. And they say, forget it. We have pistachios. We have 400,000 acres to mechanically harvest. We're not wasting our time on this. So that's one of the reasons in mechanical harvester development that you see harvesters from other crops being adapted. Okay. So just to show you how we did this with the table olives in California, we had our existing traditional orchards. You can't pull out all your orchards and turn right over to mechanical harvesting. You have to support the industry you've got. We did have some young orchards because olives, in the recent time, with the interest in olive oil, it's also spilled a little bit over into table olives. We're starting to get a few small specialty producers, nothing like Bell Carter and Musco, but still some small producers. They've put in orchards, and those orchards can be designed to be slightly higher density, and most importantly, they can be maintained to have a clear trunk for possible trunk shaking or canopy contact shaking. They can be kept smaller. And then there's new orchards where we can dictate the size somewhat by keeping them small with management and hopefully someday genetics. So let's walk through this. So here's the first type of orchard I had to deal with this was back in the late 80s. We started this. And we made the classic mistake everybody makes when they start mechanical harvesting. We designed a machine for the tree we had instead of starting to modify the tree right from the beginning. So basically, we designed this is a little GPS locator up here. We harvested into field bins. We had 3 actually very effective removal heads. All of these heads had a spirals of rods that rotated freely from one another. These heads could be moved in and out or up and down to meet the space of the shape of the tree. They were padded so that when the olives hit the rods, instead of boom, boom, pinging off sharply, they sank into the padding and then bounced off so that they didn't produce a bruise. But one of the lucky things is the California black ripe industry, we process the olive to black, so you don't see minor bruises and nicks. And believe me, you get them with hand harvest too. But this is the reason the Spanish industry, which processes the green ripe olive, is having a rougher time than we are. And so the olives would, and at the ends of these rods, they had about a 30-centimeter whip that whipped against the vertical branches and removed the olives. The olives would then drop down into this conveying belt. These were matching machines. To see this in action was incredible. But anyhow, these petals locked around the trunk from both sides. The olives were dropped in here, came down here. We had a detwigger right here, which was just a little rotating bar. Then they went up here, air leg to flush out the leaves, dropped into the bins. Bins held about 2,000 pounds, could be dropped in the orchard. So anyhow, this was the behemoth that we invented. Let's see. Okay, so there it is in action out in the orchard. And that's what it did to the trees. It not only inefficiently removed olives, you see all these olives here, it helped us prune those trees. And we learned 2 valuable lessons. If it isn't harvestable, if it doesn't harvest the fruit, that branch should be 86th. And we learned that you're going to have to adapt the tree and the machine at the same time. The removal technology was good. It just battered the daylights out of the olives. And olives are susceptible to a disease called olive knot, a bacteria that travels in water and gets into enters the branch through nicks and cuts. And obviously this did a lot of nicks and cuts. So this would just be a poster child for the first rain that comes along infecting the tree with olive knot. So what we learned, besides if it doesn't harvest, it has to be 86th, we also learned that the major factor in mechanical harvesting is canopy size. Now, just to defend us just a little bit, this business with the oil olive harvesting wasn't going on when we did this. We were basically flying on our own here and inventing this machine. So we learned what's really important is canopy size. Okay. And horticulturally, there's only two reasons to prune a tree, because trees did just fine until we came along. The only two reasons to prune the trees are to produce annual crops, regular annual crops, to feed alternate bearing and have bearing wood every year. And second, orchard operations, specifically harvestability or harvest efficiency, how much fruit you can remove, the percent of fruit that you can remove from that tree and get into a bin. Generally, and that doesn't count the fruit dropped on the ground. So generally, you're shooting for at least 70% to equal hand harvest costs in olives. This is a typical olive harvest out in Central Valley. It's the way they're still doing it. So what we decided to do was we're going to mechanically prune these trees, get them down to size. This is step 2 in the mechanical pruning here. I've already taken off about 10 feet off the top of that canopy, but I decided to lower the canopies to 12 feet and hedge in about 4 feet from the trunk. And here's the results from about 5 years of research. These trees were a little higher than most olive orchards at that point in time. Most traditional orchards are 96 trees to the acre. These were 139 trees to the acre. We hedged and topped these, we hedged every other side every other year and topped every year. The center row is one of the hedged and topped trees. And the point I'm making here is we were still modifying the machine, but we were modifying the canopy at the same time. These trees were not suitable for trunk shaking because their trunks were too large and too irregular. That's one of the major problems with olives. Also, the scaffolds started too low to get a trunk shaker in there. This would be some of our later trees when we were able to get a trunk shaker in because we trained them. And we could adapt the simple trunk shakers that they use for pistachios. So what we decided to do was invent a canopy contact harvester based on that monster that you saw. What we did was we took just a single head and we mounted it on a bobcat. Now, this is what happens when you have to do prototype harvesters. You can't make the full machine, so we put it on a bobcat and we drove it backward down the orchard and dropped the olives down here on the ground. Because, as I said, we do research, we don't develop turnkey machines. So it's always fun giving field days with machines like this because people are always pointing out to you what the machine is missing. And you're trying to tell them, I'm just showing you how to harvest these olives. This is what could work. So this machine was developed by Dr. Uriel. It's actually a modified Jatropha harvester. It was developed by Dr. Uriel Rosa and John Miles. Continued to work with it, and now I'm working with Dr. Riza Essani on this with this harvesting technology. Again, all these rods spin free of one another, or rotate freely from one another. They do not have motion in them. They rotate passively as the harvester drives backwards, and these rods engage the tree, and that 30-centimeter whip at the end of the rod is what removes the olives. And we could drive it at about 1/2 to 3/4 of a mile per hour if the trees were properly prepared to present the olives in a waterfall to the fruit. This kind of machine requires a specific formation of olive orchard. There's our catch frame trailing behind us. And the efficiency of the machine is the total weight on the tree, the total weight that's in the catch frame divided by the total weight on the tree plus what drops on the ground, okay? So we basically hedged and topped for 5 years. And these were the figures we got. This is in metric figures, but we took a standard canopy, which is about 83 cubic meters. reduced it. This little thing is touchy. We reduced it by almost 57%, the canopy. I'm going to go backwards. Okay. We reduced the canopy by 57% and got 14% less yield. So basically, what we learned was all that space inside the tree is non-functional. It's too shaded to produce fruit. As I said earlier, olives produce fruit only on the outer about 36 inches. So all the space inside the tree was really wasted. So we got 57% less canopy, but only 14% less yield. When we went to harvest it, this canopy harvested with 81% efficiency. We got about 80% of the fruit off with that canopy contact harvester. We could not use a trunk harvester on these. We got 92% efficiency here. So that resulted in a net efficiency of 8.5 metric tons to the hectare point versus 8.3 metric tons to the hectare, a non-significant difference in net yield between the pruning and the mechanical harvesting. Okay. The next kind of orchard we had to deal with was young orchards, orchards where the size could be maintained. There's some, this is the trees that had been planted in the last 10 years. What you could do with these orchards is make sure they had a clear trunk so that we could get a canopy contact, so that we could get a shaker under them. What we could also do is make sure they didn't get any that they had upright scaffolds, because trunk shaking, unlike canopy contact shaking, which, as the engineers say, I love this phrase, they say canopy contact shakers introduce the excitement into the canopy. Whereas with this kind of harvester, the excitement is introduced on the trunk. Anyhow, for a trunk shaking harvester, what you need is a stiff, upright set of scaffolds, because trunk shaking transmits very well vertically, less well out at an angle, and less well this way, and very poorly down. So for a trunk shaker, unlike a canopy contact shaker where you want a fruiting wall, this kind of shaker, you want stiff, upright branches, not too far from the trunk, mostly at a 45-degree angle. And the way we maintained it was with annual topping and every other year hedging. And keeping the skirts clear about 1 meter from the ground. So we used a trunk shaker here. This is Eric Nielsen up in Ridley. And it cost, these are slightly higher density trees, because they started at 90 trees the acre and we interplanted. It cost about $1,000 an acre for the initial pruning. When the man got started, he was a little slow. He was taking 30 to 40 seconds per tree. Just to give you an idea, a pistachio trunk shaker spends like 6 seconds actually shaking. But initially, they were shaking a little too long. But by the end, the operator got to where he could do about 129 trees to the hour, 2 tons to the hour. So in a long day, they could harvest 20 tons, 4 to 5 acres. And the quality was very good. We took all our fruit to the receiving station blind, and we got 95% acceptable. This is actually a hand harvested control. And you'll notice that they got little nicks too, just like our fruit does. Okay, so when we did the economics on this, let's just say we had 30 tons out there, okay? 4 tons the acre on 7.5 acres. That was our experiment. That machine produced about 77. Produced about 78% efficiency. This thing is very touchy. Produced about 75% efficiency. We gave the pickers a pass and said they were 100% efficient, but frankly, they're usually more like 95 to to 93 to 95% efficient. What we did was went in and stripped the trees afterwards. We gave both each 10 hours. It cost 200 per ton. We figured, did a cost analysis. We figured it cost 200 a ton to mechanically harvest. And this is actually quite a low harvest for low price for hand harvesting. Now it's more like up to 600. And this price is not under your control. By the end of the season, we were able to get this down to 134. So the result was that the trunk shaker netted insignificantly different, but approached the compensation point with hand harvesting, and you didn't have to deal with all the logistics of a harvesting crew. One problem with trunk shakers is you do have to, with olives, they have irregular trunks. You have to watch out for what we call scraping of the trunks. This is usually produced when when the operator clamps on and starts to shake simultaneously. You should clamp first and then start to shake. Okay? Third type of orchard is new orchards, where we can dictate the size. And we started to work with this up at Nichols Soils Laboratory up in Arbuckle. We put in 200 trees to the acre. That's moderate density. We raised it on a trellis because we had this idea. We didn't really know. We were looking at oil olives and seeing that they had a wire. So we decided we'd do a wire. We did them at 1, 2, and 3 meters. And we did one person wanted to tie to the wires. What I wanted to do was as the branches became stiff, I just wove them through the wires on opposite sides of the wire. We were shooting for an espalier shape where all the spreading of the branches was straight in the row. So I put a wire at 4, 6, and 8 feet. We kept that tree down to 12 feet and raised the canopy. We didn't want any more than 6 feet wide, and we wanted a good 4 feet below us, just in case we could also use a trunk shaker on these trees. We designed them to produce both a waterfall on the side with hedging and topping, and use a canopy shaker on the trunks. Okay. And this is the kind of shape. This is standing in the row, looking back at the tree. We were shooting for this espalier shape, spreading the canopy in the row, no big thick wood, any thicker than your wrist coming into the row. So over the years, we developed a pruning program that was like this. Olives bear their fruit on 1-year-old wood. So if you mechanically prune an olive, you are taking off your bud wood for the next year. Horticulturally, mechanical pruning is all wrong because it removes your fruit for the next crop. So anyhow, this is how we developed managing this orchard with mechanical pruning. 2011, we topped at 10 feet, and on one side, we hedged 2 feet from the trunk. The next year, 2012, we topped at 11 feet. I had crop on the far side, and this is my 2013 crop because last year I hedged it, and I grew new shoots, and they've made crop the following year. The next year, here's my 2013 crop, hedged 2 feet and 3 feet from the trunk this time, and my 2014 crop is up there. So what I was doing was essentially moving the crop around the tree and maintaining the tree size. So we could use a trunk shaker. Oh, want to make this point. Because trunk shaking has less force than direct canopy contact, this is a situation where we have been trying for years to use ethrel, the plant hormone that the plant produces naturally, but it's available in a chemical formulation called ethafon, just to initiate the cascade of ripening and the forming of the abscission zone. We have not been successful thus far. It either does nothing, or it takes off all the leaves or all the fruit and the leaves. And the tree can tolerate about 25% leaf loss, and then you harm your next year's crop. So we designed this for the trunk shaker and for our canopy contact shaker. And here's how it shook out by the end. The trunk shaker achieved 77% efficiency, and the olives were marketable. And the thing about this is that shaker is commercially available. For the canopy contact harvester, we got up to 92% efficiency. The fruit is marketable, but we're still stuck with a prototype with no catch frame. Dr. Riza Asani we're working right now on a new harvester that actually combines both trunk shaking and canopy contact at the same time to take advantage of both methods. One thing about the trunk shaker, it tends to leave the olives in clumps. So if you have more than a ton left on the tree, it's worth it to send into hand crew. One, the tree is smaller, and two, because the olives are in clumps, the pickers will work there. With the canopy contact harvester, it tends to leave the olives all over the tree, and the crews don't want to bother with it. Here's one of the problems with mechanical harvesting. For black ripe processing of olives, we don't like to see any more than a teeny bit of light. I can't even find it. A teeny bit of light purple on the skin of the olive. It doesn't process well in the oxidation steps in the processing, and in the decrease of the oleoeuropin, the bitter principle in olives. So you don't want to see purple olives in the bin. You're going to get downgraded for that. One of the things about mechanical harvesting is it's indiscriminate, and you can't prevent it. What we have developed is increasingly we're just as we develop those hedgerow canopies, we're just topping every year and sacrificing the crop at the top of the tree where it ripens sooner and puts purple in the bin. And that's very much what they do with oil olives now. They just top the top of the tree because those olives up there are overripe compared to the olives on the vertical sides. So in conclusion here, whenever you start to do something with changing an orchard, you have to be clear on what your goal is. And for us, we're working with changing the existing orchards, just trying to reduce the size with mechanical pruning primarily and some hand pruning. In young orchards, Musco is now giving away free trees, encouraging people to convert their young orchards to mechanically harvestable. And we're trying to plant the young orchards at a much higher density, what we call moderate density for oil olives. And the only real breeding program for genetics of mechanical harvesting is being conducted in Spain out of Cordoba and Sevilla. And I'd like to leave you with the one point that with adapting mechanical harvesting, it's an integrated system. You've got to work with the canopy and the machine at the same time, and possibly even the chemistry if we're able to get Ethifon to go. And that's my presentation. I'll take questions. I forgot to say I'll take questions during the presentation, so I'll take them now. How am I doing on time?
Hey, Louise, really informative. Thank you. I'm not going to give you softball. I'm sorry. So this last few slides you talked about summed up all the work you've done. I'm sort of wondering, we can talk about this in around people we prefer, but what do you think is going to happen? Do you think that the tech is going to get better? The costs are going to go up to the point where farmers are desperate enough to make the tech work, or the market's just
well, so the question is, what do I think is going to happen? And we've gone from 37 to 14,000. I'm really happy we have the oil olives in front of us, or right alongside of us, because some of the oil olive people are looking over the fence and saying, making olive oil is tough, but making table olives isn't all that hard. So some of them are starting to slowly get into that business. I admit that right now we're in a bad position because most of the people that pull out olives put in pistachios or almonds, because especially pistachios can take class 2 ground. I bet we can grow them with, they grow each right now we recommend a meter of water, 36, 39 inches. But if we grew smaller trees, I think we could get that down to maybe high 20s in the inches. On the other hand, olive oil takes about a foot and a half, about 18 inches of water. And as I mentioned, one of the major processors is now allied with, has been purchased by a Spanish company. So they're technically not a California company. You know, they're supported otherwise. I'm hoping that it survives as a legacy industry, but the existing orchards are going to leave. If people don't plant new orchards, we won't have an olive industry. The only thing that'll save it is people will want a crop that's can take less quality ground and less water. So the outlook actually does not look good, truthfully. The growers have been very reluctant to adapt mechanical harvesting. I only have 2 or 3 that really do it. Some of them, I'm getting a few more converts every year when they can't get a hand crew. Because the hand crews, we're competing with grapes and the early citrus. And they'd rather harvest those. No.
Maybe a little off topic, but I used to see a lot of varietals on the shelf at retail, you know, like Asana or Tina, and now it's hard to find. And it's all blanks of some necklace sort. You know, what's going on there?
Okay, so you know, California is primarily, I should have said this, the Manzanillo black ripe table olive, pollinated by the a Sevillano row about every 200 feet. Musco won't take, excuse me, Bell Carter won't take the Sevillanos anymore. And actually, Bell Carter, because they're foreign owned, is getting in foreign olives more cheaply than they can buy them here. So major part of the olives come from there. California's industry is monolithic. Only the small specialty producers like Maurice Pena will produce what you're talking about, because what our olive market is the retail market in the supermarket. We long ago lost pizza. Oh, excuse me. We long ago, thank you. We long ago lost Taco Bell and all the food service. They all use Moroccan and Turkish olives. Our production goes solely into supermarket shelf space. And the years when we have alternate bearing and we have to source from Argentina or Turkey or Morocco, which is the reason Bell Carter did what they did. Be bought by a foreign company so they don't get taxed for bringing in the olives, because we have tariffs against imported olives. So the reason we don't produce those cultivars except them from small companies like Adams or Maurice Pena. And I want to tell you, all those olives in the olive bars are imported. So buy them in the cans, okay? Marie, did you have a quick question?
Yes, I do. Louise, could you comment on what have been the some of the improvements coming out of the genetics program in Spain?
So they focused their program largely on first tree size to those olives that you saw in the mechanically harvested oil olives. Those things crop up in the second year. The minute they crop up, they stay small. They look like a little fuzzy dog. And then the second thing is they're trying to breed for a tougher skin, so no nicking and less bruising. Then the other thing they're doing is not genetics, but they're trying to put them in cold caustic soda in water in the field. Is it sodium hydroxide, I think? I've forgotten the exact chemical, but they're putting them in cold solution in the field to deter the development of the bruises. So it's focusing on trying to have the Hoji Blanca is a tougher olive, and they have a new Manzanilla there that's tougher. And this is not good news, because if they develop that, then they're going to come take our market. And sadly enough, we need that foreign production the years we don't have olives, because if we don't supply our suppliers, we'll lose them. So the largest company down in Tracy, Musco, which the one thing probably you go in the supermarket and you see all those different labels. Well, all those olives go down the same line, and then they get to the canning room, and there is boxes and boxes and boxes and boxes of different labels, and they're all the same thing. So, you're welcome.
I'll take one question from the Zoom chat.
Oh, would you like to read it to me?
Yes, so it says, can you share about the criteria for using a trunk shaker? Thinking about the stem diameter, required force to detach the fruit weight, and trunk diameter.
Okay. So for the first thing you need is a clear trunk up to about a meter. So you can't have the scaffold starting low. You don't want the scaffolding starting below 4 feet, meaning the formation of the new branches. Then the trunks, working with pistachios, I have found trunk shaking in pistachios decreases after about 50 inches in circumference. So I'm just going to transfer that to those, though the big thing with the larger olive trunk is it's irregular. They don't have often smooth trunks. Then you want the branches no more than 3 to 5 and more likely 3 scaffolds. You want them at 45-degree angles. You don't want that canopy any more than 8 feet in either direction. Even though that's small for the trunk shaker, because most of the trunk shaker now, the beds are 24 feet. They're 12 feet. So you can space within the row at 16 and between the rows by 8. We've taken it down to 12 in the row and 16 between the rows. You can even go a little bit more than 202 to the acre. And you do want to top annually and hedge every other side row every other year. And fruit weight to fruit detachment force, if it gets below a ratio of 2.7 fruit detachment force to fruit weight, you can't get the olive off. But that's not a problem with table olives because they're much larger than that in size. And the final thing is, let's see, fruit detachment force. Did I miss anything that he asked? I gave tree shape, I gave pruning, and I gave trunk size. I'm going to do it graphically, but they probably would shake well up to 30 inches in circumference. And that's about a 25-year-old tree. So maybe what we're looking at is these trees aren't forever trees. Maybe we renew the orchards every 20, 25 years if you're going to use trunk shaking. Big advantage of trunk shaking is it's out there. The trunk shakers are available. And usually by then, pistachio harvest is over. So they're willing to come.
Sorry, thank you. We have a related question that say, access to high density field, is it a challenge for trunk shakers?
That orchard I showed you was 16 by 18, I believe, and we didn't have any problem with the trunk shaker. And you could take it down to 12 feet because the beds are 12 feet on the trunk shakers.
Thank you so much. Do you have one more question?
Oh,
One quick question regarding this, regarding the enhancement of the fruit removal using ethanol.
mhm.
As you know, the environmental factors affect how rapidly you would generate ethylene and things. How much did you experiment with a time of day and various factors to try to improve the ethanol? Did you work on that at all?
So what we're trying to do, we're working with the Ethafon right now, and what we're doing, I'm trying to dial in when to apply it. So we are trying to determine by growing degree days from the fruit growth phenology from full bloom. So I'm accumulating the growing degree days from bloom above 50 degrees Fahrenheit. That's when olives start to grow. And with this year, last year we got some preliminary data that we're going to try this year. What we haven't worked with is ambient temperatures, just like you use for thinning in the spring. But I am sure that if the ambient temperature spiked right after or before we applied the Ethifon, I have an idea we get a stronger effect.
So when do you apply the Ethifon? What's your?
We're trying to do it when we've hit about 2,500 growing degree days, I think is the number, and when the fruit detachment force starts to drop below 1 pound. We go out and use the little pull tester, and when the fruit detachment force starts to drop, then is when we apply the Ethifon.
Or I was referring to the time of the day.
Oh, the time of the day. Oh, we usually try to do an early morning application when the winds are still. And we usually don't like to spray during. We want to keep that Ethifon wet as long as we can for uptake. So we usually do an early morning application. We would never do one during the day.
Right. But you haven't tried doing one at night?
No, we haven't. But if you think that'll work, we'll try it.
In the tomato industry, I know that they work a lot with that, trying to get the Ethifon to work more consistently. And, but I don't remember now, and I don't know the details, no. But I just wonder, you want it to be the Ethifon to be released, but not so rapidly. And so I wonder if there's something there about the environmental temperatures at the time of the application that would affect the result, both from the standpoint of the damage and result of the leaf crop as well as the.
Now that's a good suggestion because, as I said, we try to keep the wetness as long as we can. We put it on with spreader sticker, a mild spreader sticker, not oil, so that we can have the uptake more sustained. So that'd be a good idea. So.
Thank you. Does anyone else have a question?
My question is that I have never seen a trunk shaker. So do they have pad handles so that they don't damage the?
Oh, so the trunk shakers, it looks like a great big clamp, and they're padded, and there's all different kinds of padding. Some of them are liquid filled to not damage the trunk, to be softer, and to conform to irregular shapes. But they're all really heavily padded with foam. Then what happens during the season is, it gets shredded and stuff, and the guys go out there and put carpet on them and stuff like that. But they are definitely padded.